Jai Hind everyone. Myself is Nikhil Kumar, Department of IT in Ajay Kumar Garg Engineering College. Today I have a lecture on the Tafl, Theory of Automation, Automata and Formal Language. The code is the BCS 402. Basically, it is for the CS and its allied branches. Today I have a lecture on the partition method for minimization algorithm of DFA. Basically, before to introduce this one, I have introduced that I have two lecture in the Tafl regarding Tafl introductions and the minimization method in the briefing. So I firstly do the briefing for what I have already covered in this Tafl lecture series. So in the first lecture we have discussed what is the DFA. Before DFA introduction, we have already covered the language and the keyword tokens that already covered keyword alphabets and DFA and NFA with epsilon, without epsilon. And in the last proper lectures, we have covered the minimization method. Minimization method for the DFA model. Basically, we have covered the minimization method for the DFA to reduce the states that I covered in the capital Qs, that denote in the capital Qs. So these terms are already covered in the previous lectures. So we will start now today's topic, that is the partition method for the minimization algorithm. As we have already discussed in the last lectures, what is the minimizations of algorithms in the DFA model? Basically, the minimization of DFA model contains the reductions of states that are already mentioned in the finite automata models. Let's suppose there are three states that are Q0, Q1, Q2, where Q2 is the final state and Q0 is the initial state. And we want to reduce if any possibilities outcome in that particular models that we can reduce. Let's suppose there is only one of the state is also covered in this. There are four states, Q0, Q1, Q2 and Q3. So firstly, the objective of this algorithm is to reduce the number of states so that the functionality and the complexity becomes reduced. And and how we will do it? We will do that to reduce the or we can say eliminate the inaccessible state. Firstly, we will do the eliminate the inaccessible state. And what the next thing we can do, that we merging the state that have the same output, and the basic principle of the DFA model will not be changed. So what we will do, we merge some states so that the output of the particular model will not be changed, and the functionality will depends on the current scenario that are the given states. In this particular questions examples, we have the four states Q0 to Q3. So our basic principles to minimize this one, to reduce the states. So in this particular question, what we can do, we can eliminate this one, that is the Q3, that is considered is the inaccessible state, that because we cannot cover the Q3. It is basically the fundamental for that, what is the unreachable states. So it is very important to know firstly what is unreachable state. Unreachable state is covered, can we say that all the state is known as the unreachable state if we cannot access we cannot traverse from the initial state. Let's suppose we have the state Q naught here and have multiple state in any particular model. Let's suppose this is a model, DFA model contains some input symbol A and B. Can you say that we can be reached anytime Q2 for the Q3 at any moment we can be reached Q3? We can reach Q naught, that is the initial state, Q1 from the Q naught. We can reach Q2 also from Q naught and Q1 traverse. We also reach Q2. So, but not, we can never be go through the Q3 from any directions, because Q3 is the intermediate state and we cannot go through from the Q naught. So, Q3 is known as that, in this situation is known as the unreachable state, because Q3 cannot be accessed from the Q naught. So, in this method, partition method, what we will do, we also, the first step will be to eliminate the inaccessible state which cannot be traversed from the initial state. The first step will be to eliminate such states, the number of states which cannot be accessed from the initial state. The next state, the next step will be to cover, let's suppose there are Q naught contains Q naught to Qn total states. Okay, Q naught to Qn total states. Then what we will do? We cover the state Q, that means the set of states that are denoted by Q, into two sets which is denoted as pi naught, that is a zero equivalence, in such that the state that are generated from the non-final states and the states that are generated from the final states, that's the set of the final states and the set of the non-final states, and it is denoted by the pi naught. So what we will do, firstly, the first step will be to eliminate the inaccessible state. The second step will be to design the transition table as per the given model after eliminating the inaccessible state. The next step will be to generate the pi naught. Pi naught contains the two set. The first set contains all the states that are non-final states. Okay, and the second set contains the final state sets. Final state set. Okay, so the next state, the step will be the pi, to calculate the pi 1. The pi 1 will be calculated from the pi naught states. Okay, so what we will do, let's suppose there are the states Q naught, Q1 and Q2, and here is the Q3. Okay, so what we will do, to calculate the pi 1, we check Q naught and Q1 are basically the starting two states. We check in the transition table the Q naught and Q1 functionality. What will be the next state in the transition table for the Q naught and Q1 continuously, similarly, and check the value of the for the given input. Let's suppose the given input is A and B. So what is the next state after apply the given input A and B? If the next state exists, belongs to the same set, then what we will do, we use Q naught and Q1 in the same set. Otherwise, if the next state exists in the different set, then we apply Q naught and Q1 in the different set. And this procedure is continuously do for the Q naught, Q2, Q naught, and let's suppose there are other states, then we will do Q naught and Q3. And we will do the same thing for the second set, and this procedure is repeated. Firstly, we will calculate pi 1, that is the first equivalent. Then the next one is the pi 2, that is the second equivalence. The second equivalence is calculated from the value of the pi 1. The pi 1 values contains the number of sets and contains some states. So firstly, we will take two elements that are the two states and check in the transition table that the value, that is the next state value, is exist in the this one in particular one set or different set. If it exists in the one set, then it will exist in the same set. Otherwise, it will be exist in the different set. And this procedure is applicable till the pi n, that is the pi n equal to pi n minus 1. That means the two states that are the particular different states, two different states contains the same number of sets value. Then the number of sets that contains having basically contains the different states, updated state, we can say upgrading states. So what will be the output? The in starting we contains q0 to qn states, but after doing these process, we contains less states than the starting states, and this is the basic principle of the partitioning method. So today now what we will do, we do the questions for that one. Okay, we have the very basic questions that covered in the AKTU exam also. So firstly, what we will do, we write down the questions and then do the solution for that. State q0, q1, q2, q3, q4, q6 and q5. Q6 is the final state also. This is a particular models that is mentioned in the questions. It is basically the questions. Such type of questions are complex in nature, but when we will solve out, it is not take much time to calculate. For the competitive exams, we will not follow such steps because it is it take time to calculate and have some complex parameters. Yes, it is done now. So what we will, the first step in this question, basically we have a DFA models, and in this model we have some state q0, q1, q2, q3, q4, q5 and q6, total 7 states. So in the starting we have q contains 7 states that that are q0, q1, q2, q3, q4, q5, q6 and q7. Okay, where q0 is the initial state and the final state is the q6. So this is the basic parameters. Okay, and the given in the question. So the first step will be for the partition method is that to eliminate the inaccessible state. In this particular questions, we did not have any inaccessible state. How we can find out that from Q naught we can traverse Q1 by Q2 by using this step. All the state will be covered from the Q naught, so that we cannot calculate that there is any inaccessible state. So what will be the next step? To find the transition table from this. To calculate the transition table, it is very simple. We have the input symbol A and B, and the given state are Q naught, Q1, Q2, Q3, Q4, Q5, Q6 and Q7, where Q7 is the final state and Q naught is the initial state. That is the segment in transition table. So directly we will do write down from the, we can calculate transition table from the model, as we know very well. Basically, in this given questions, we have only Q naught to Q6 states. So here the Q6 will be the final states. So in this given questions, these are the parameters that are the first steps and second step. Firstly step is to eliminate the inaccessible state. Second step will be the to generate the transition table from to after eliminating the inaccessible state. So now the zero equivalence will be, that is the pi naught contains the Q naught to Q5 state, Q naught, Q1, Q2, Q3, Q4 and Q5, and the next set contains the Q6. That is a single element, that is the final state. It may be a group of state. So the next step will be to calculate the one equivalence. The one equivalence will be calculated from the Q naught using the transition table. To calculate the pi 1, what we will do? We check Q naught and Q1 in the starting and check in the table Q naught and Q1 where it exists. It exists here, Q naught and Q1. What will be the next state after apply the input symbol A and B? Q6 and Q naught is the next state after apply the input symbol A. Okay, and where it exists? Q6 exists in this set and Q naught exists in this set. Basically, these are two different sets. If two different sets exist, the next state. So what we will do? We contains these elements in the different set. Okay. So what we will do? We will do next. Check Q naught and Q2 and where the next state will be exist in this transition table for the case Q naught and Q2. For the Q naught and Q2, the next state will be for the given input A, Q6 and Q3. That means Q6 and Q3, basically these are two different set. These the next state exists in the two different sets. So what we will do, we introduce place Q0 and Q2 in two different sets. One more thing that I think should be mentioned here. Let's suppose Q0 and Q1 for the input symbol A contains the next state in the same set. So what we will do next, we will check the for the input symbol B for the same set. For the same state, we will check the what will be the next state for the input symbol B. If it also exists in the same set, then we apply the given Q0 and Q1 in the same set, otherwise in the different set. Okay, so it exists in the next will be the Q0 and Q3. We will check the position of Q0 and Q3. Q0 and Q3, that is the for the input symbol A, Q6 and Q5 contains the two different set. It contains here and it is here. So what we will do, we also mention in two different Q3 will be placed here. Q3 will be placed Q3 will be placed here. What we are doing that, firstly check Q0 and Q1 next position, that means the next state after apply the input symbol A and B. If it exists in the same set, then we will exist in the same set. Otherwise, Q0 will be singly placed here. Okay, for the Q0 and Q4 pair, Q0 and Q4 pair, what will be the states? Q6 and Q6. Q6 and Q6 contains the same set. That means it will be placed here. And for the next input symbol B, what will be the next state? Q2 and Q5. Q2 and Q5 contains the position for the next state in the same set. This one, Q2 and Q5. So what is the means of this one? Q0 and Q4 contains the same set. And for the Q0 and Q5, it is the last one, Q0 and Q5. Okay, Q6 and Q2. It contains different positions. Okay, different locations in the different sets. So that we apply Q0 and Q5 in the different sets. And Q6 is remaining and a single entity is mentioned here. Okay, no doubt. So what will be the next step? The next step will be to calculate the two equivalence. We will calculate the two equivalence from this set one, Q0 and Q4, and check out that the Q0 and Q4 position in the transition table contains the next state, contains the in this state, this set or different set. That means, let's suppose when we calculate Q0 and Q4 and check in the transition table that what will be the states, next state after apply the input symbol A and B, if the next state exists in the same set, okay, maybe here, in the same set, then what we will do, if it exists in the same set, we contains Q0 and Q4 for the same set, otherwise in the different set. So it is easy to calculate pi 2 from the pi 1. We write down directly using the steps that I mentioned. Actually, Q6 is the single state, so we will not do for the Q6 because it is a single state. It will be exist in a single position, single set. Q1 and Q2, Q3 and Q5. When we calculate the three equivalence, unexpected, as expected, we have the same set values than the previous one. Q2, Q3 means no change here. No different set values occurred here. So what we will do, we check that pi 2 contains the same value as pi 3. So what will be the, we find out that there are only 4 states available, that is this one, this one, this one and this one. In starting there are 7 states Q0 to Q6, but we will reduce this one into 4 states mentioned here. So our next step will be to find the updated transition table from these states, and we write down here the first state is the Q0 Q4 for the input symbol A and B. We also calculate these updated transition table using these state. Follow the transition table, this one. For the input symbol A, the Q0 position contains Q6 and Q6 is the single state. For the B input symbol, for the input state Q0 and Q4, it contains the Q2, and Q2 contains these terms that are the merging states. So here in this updated transition table, what we will do, we contains Q2, Q3, Q5 subsequently in the same state. The next state is the Q6. Q6 is the single state. We will use Q1 and Q5. Where is Q1? Q1 is the single element, and where is Q5? Q5 is Q2, Q3, Q5 panels, contains a set of Q2, Q3 and Q5 element. The next state is the Q1. Q1 contains Q0 and Q2. It is the single element Q0 and Q2. The next state is the Q2, Q3 and Q5. Q2, Q3 and Q5. What will be the next state? After apply the input symbol A and B, Q2, for Q2, the input symbol A apply after the in the state Q2, that is a Q3, and Q3 covers in Q2, Q3 and Q5 states. Q2, Q3 and Q5. And after apply the input symbol B, Q2, Q3 and Q5 positions will be Q0, and Q0 cover in the Q0 and Q4. Q0 and Q4. Q2, Q3 and Q5. Q0 and Q0 cover Q0 and Q4. Q0 and okay. It looks so nice. Final states. Using this transition table, we can calculate the updated transition model, that is the DFA model. Thank you, class.